more good news, actually. Now we are collaborating with Republic Rupia. The content, all of our contents, the educational contents here, is going to have is going to be subtitled in Bahasa Indonesia. So we've been super excited because we are initially an expat community, and this is going to help us expand the possibilities of sharing our expertise and spreading the knowledge from the actual founders, developers of blockchain to Indonesia. So that's also why we're stressing about the microphone. So Al is going to help the microphone to pass from hand to hand for the questions. Thank you. Yes.
Thank you. Oh, yeah. Yeah, I'll sit. Okay. Can I? Okay, basically, I wanted to go back to the start just to situate you guys, but I don't know how to do that, so I'm gonna try to say it instead. Basically, the rest of this talk is gonna be kind of the how to get started in MEV, I guess, or how to find opportunities. So this section will be the MEV at the application level. So basically, how do you find an MEV opportunity, right? What are they? Where do they come from? Is it a good thing or a bad thing? And the next section will be, once you found an opportunity, how do you execute it, right? Which is what we're talking about, just the game, basically, which chain you're on, and yeah. How do you win the opportunity, basically, with all the other people fighting you? Okay, so this is Flashbots. Keep coming back to this. Basically, they've been at this since 2018. They kind of started the movement. If you actually want to get started, honestly, you should just like stop listening to me and go read their docs, do all the examples, and like you'll learn a lot more, much more than you will today. But otherwise, this is kind of this is the old picture, but this is kind of the way that I like to situate the different protocols on Ethereum in this case, but many chains. Right, so you have the layer 0, and then basically you can start by borrowing money. So you have the lending protocols and money markets here, and then you have all the, useful and crappy application layer here where MEV kind of sits and happens. There's some here, but so the point is, you have liquidations, right, in money markets, because if you're borrowing money, you have liquidations. So this is like liquidations. All of the other opportunities are here in these protocols, right? So obviously the DEXs you can trade. When you have these the set protocol, you can kind of arbitrage because they're also trying to do kind of on-chain ETF thing. Chainlink, you can front run whenever there's a new update on the price. We were talking about this before. So that's the idea. And then you have these super mean guys who are kind of front running the front runners. So it's just becoming a really fun game. So we're going to touch on all of these. Okay, so in the previous presentation, he started with like some kind of simple example. I think he gave these 3 liquidations and their NFT. There's also these things, right, which is just long-tail opportunities. You'll hear this a lot if you look at Flashbots or anything. It's basically everything that is kind of secret, right? So it can be something as crazy as like there's a new on-chain governance update that is coming up, and it's going to change some whatever risk parameter, and it's going to like create an opportunity for liquidating. And then if you can come in and just kind of flash loan a bunch of money from the governance token, put it in, vote, change that. I mean, there's a bunch of crazy things happening. But let's go a bit technical into. Basically, if you can leave this room with a single kind of application in mind, I think it should be arbitrage, because as we've seen, most of the money comes from here, and also like kind of ties back to the normal kind of securities markets and everything. But arbitrage on AMMs, right, on DEXs are super different just because of the mechanisms. So if I say X times Y equal K, does that ring a bell? Can people who know what that means just raise their hand? X times Y equal K? Okay. Okay, so Uniswap, have people traded on, anyone who has traded money on Uniswap? Okay, good. Okay, good. Awesome. Okay, so basically Uniswap just implements the X times Y equal K AMM. So I'll take a bit of time and try to explain basically when you're trading against this, what's happening. So this is the pool of reserves of tokens, and you have 2 kind of players that come in. you have the traders who swap against these reserves, and then you have the liquidity providers who deposit and withdraw their assets. The difference with kind of, the traditional market makers is that here the price that the swappers are paying is deterministically dependent on the reserves and is not a function of like market makers kind of dynamically going to change their positions. Unless you heard of Uniswap v3, which changes the scheme, but we won't get into that because here we're staying with the OG Uniswap v3, v2 arbitrage, right, which is a simple thing that everyone's using probably. Okay, this is your curve. This is the x times y equal k. This basically just represents, right? So if you've done basic algebra, right, you just solve for y as a function of x, you divide by x, and you get y equals to k over x, and you can just pretend that k is 1, so y is equal to 1 over x, right? So you get these curves. And as you increase k, so k is the liquidity, right? So can I go back? Right, okay, so when liquidity providers come and they deposit money, basically they're increasing the reserves, and that reserve is the k parameter, right? So as there's more money, the curve kind of moves here. So as an example, let's say we start here, right? So there's 18 of token 0 and 6 of token 1 sitting inside the pool. And then a liquidity provider comes in and he deposits assets. So let's go backwards here just because I don't know. So he deposits assets, right? So then we get to this new reserve here. Now there's 70 of token 0, 22 of token 1. When a swapper comes to trade, basically what you do is you just, so to know the price that you're paying or the amount of output tokens that you're getting, you literally just look at this curve, right? So here in this case, the trader would be inputting, okay, that's a bad example. He will be inputting this T1 token, right? So the reserve is here, and then he's inputting T1, like 40 minus 23. So he's putting 17 tokens of T1 into the pool. And then you just look at this curve, right? So if you were here, you input this much, just look at the curve and where it intersects, this is the amount of tokens that you will get. So token 0, he'll get 70 minus 40, so he's getting 40 tokens for this. I'll keep going, stop me if it doesn't make sense. But the point is, like, this is your slippage, right? So if you look at the tangent here, this is the instantaneous price of the token. So to look at the derivative, so the price that you would be paying if you're trading like a very small amount is basically this slope, right? Because you're moving like this. But if a whale comes in and he's trading like a lot of money, then he's going to move this point very, very far. And then he ends up paying, instead of paying this slope, he's paying this price, right? Because he's moving here. So you can see that if you're a whale, basically if you're trading a large amount of tokens into a pool that has like a small, like not that many reserves, you will be incurring a lot of slippage. And on top of that, you can get MEVs. So let's get into that. I'll pause for a sec. Does that make sense? Yeah. Okay, so this is all there is to know, basically, right? So you have a state of a pool, and then you have people trading against it, and they change this state of a pool. Everything is deterministic because the blockchain just kind of like creates like a linear chain of transactions, and these are executed one after the other. So we'll look into basically an MEV finds these opportunities when the price changes, either in a single market, two markets, or n markets. So let's start with the single market. When I say single market, I just mean like a single AMM pool, right? So let's say an ETH DAI pair or something. Okay, so this is your Uniswap v2 interface, and you can see here that basically if this pool has, I don't know how many tokens, but you're trying to trade, let's say 0.1 ETH for DAI, because of the size of the pool, you will be incurring here, saying price impact is minus 0.48%. So it just means that basically, right, it's the kind of, the amount of slippage you're incurring by moving on this curve as opposed to like the marginal price that you would be paying. And then on top of this, you have the MEV slippage tolerance. So someone asked before, I think, how do you protect yourself, right? So this is the parameter. In this, you can click on this setting here and you can go change this, right? So it depends basically if you want your transaction to be included faster, then you probably want to increase the slippage rate because, you know, you have like, basically if you reduce this to 0, there's a chance that your transaction will just be canceled because if you're trying to trade and then someone comes in and trades before you, it kind of changes a bit, right? The slippage that you would be incurring. So you were expecting to get this minus 48, but then someone, not an MEV bot, just a regular other user kind of transaction comes before you, it won't work, right? So anyways, you can play with this parameter, and this basically is saying, okay, like 0.5% of my transaction data on top of the slippage price is going to some bot that is going to steal it from you. That's like exactly what it means. So graphically, what's happening is, right, so this person that's putting tokens into the pool, so the user is the group. Can you guys see what so the user would be kind of, this is the current state of the pool, and he would be trading, right, this many tokens, the blue curve. So he's expecting to kind of get here, right, and get this amount of tokens out. What's actually happening is he puts the slippage protection, which is the 50% here. Then the on-chain, like Uniswap contract will just put the slippage protection, boom, right here. And then this is saying, okay, basically anyone can front, so this is a sandwich attack. Anyone can front run me by buying before me. So moving the price against me moving like the assets in the pool. And then I will get less asset and he's just gonna sell them back against me. So this is a sandwich attack. When we say front running, back running, it's basically just this if you're doing one of the two because, I don't know. Okay, one actually good reason is that if you kind of need Flashbots to do sandwich protection because in Flashbot you send bundles, so you can actually make sure that these three transactions come together, like atomically, whereas otherwise on other chains it's very hard, so you'll see much more like back running, less sandwich. Yeah, so just remember, if you're trading a lot of any whales here, just be careful if you're trading in a single pool. Don't do that. Just go trade on 1inch or some DEX aggregator because it's gonna kind of spread your tokens across like different pools and make sure that you don't incur like a lot of slippage that is just going to bots. That's kind of the key takeaway. Okay. Right, okay, so that was one market, now we're moving to two market. I'll try to go faster. Basically, I'm sure everyone knows here that DeFi is a game of forking. So if you go on DeFi Llama, you have this fork section, and you can look at Uniswap and all the protocols that fork Uniswap, which means they just took the code on GitHub and created the exact same thing on either another chain or the same chain. I think there's like 400 something of this. It's a bit ridiculous when you think about it, but this creates like opportunities for arbitragers to arbitrage these two markets. Right? So now the difference with the previous case is that we have two curves, which are not kind of the same pool over time. It's just literally two different pools. So let's say this is Uniswap, this is SushiSwap. And then the price of your tokens on both would be like, let's say here and here, then you have the same price. So there's no arbitrage opportunity. Right? Here and here, same price, no arbitrage opportunity. So if a whale comes and trades on one of these only, like he will move the equilibrium point, right, and then create an arbitrage. So basically, if you sell and bring the point here, and this SushiSwap pool is still here, then there's an arbitrage opportunity to come and just kind of sync these together, right? So you buy one of them and you sell the other one, and you make money. And on top of that, you can actually compose both of those, right? So you can first front run, like sandwich the transaction on the single pool, and then whatever is left, you go and like trade with the other DEX, right? So it just never ends. And market arbitrage is even more complicated. So sometimes you won't have a single, like two pools, right? You don't even need a fork. Basically, if you have a single like DEX, let's say Uniswap, and yeah, let's say there's no whales coming in to trade and there's no other market to kind of find an opportunity. You can still find opportunities within the Uniswap pools. So here in this case, you would be trading, basically just you kind of move around the graph of coins. So you're selling USD for Tether, for the Steel, for Keeper, and then bringing it back. And like somehow magically, like you make money. Which is kind of funny because when you think about it, basically if you're selling, if you're trading, I don't know, you're in my case, Canadian dollars for IDR. And if I'm trading a lot, I also, basically I'm not only thinking about all the markets like IDR Canadian around the world, I also have to be thinking about all the other currencies, right? Because everything's related. So even if I make sure that I'm trading like on separate exchanges, Canadian IDR, I might still leave a lot of money on the table by people who are going like to trade my Canadian for US for like Japanese yen coming back to IDR. There's just always money, like there's just money everywhere. Okay, so this is a bit technical, but this is kind of the algorithm that bots use if you want to find these cyclic arbitrage. It's called Bellman-Ford. Basically, it just finds, you have this graph of exchange rates. So basically all the weights here are the exchange rates. So if I'm putting $1 USD, I would get a like 0.66 GBP. I put 1 here, I get 1.62 CHF, blah, blah, blah. And there's a when you trade, you get back more than $1. Right? You put 1, you go around the circle, you have more than $1, you make money. So to find this, it's a bit technical, but basically the algorithm Bellman-Ford kind of will find cycles, but it can't work with multiplication, only works with addition. So what do? You just take the log and then you bring multiplication down to plus. So you just take the log of all these assets, right, and log of the multiplication is just log of plus. So then here, instead of having the actual exchange rates, you have the log of the exchange rates, and then what you're trying to find is just, again, a negative cycle, because if this is more than 1, you follow the math, you just get that. You find a cycle that sums to less than 0, you make money.
Can you give an example, man? I'm like, I saw that, and I'm still lost. Yeah.
Okay, let's go. Question, please. Let's slow me down. Yeah, I mean that's exactly what Bellman-Ford is doing there. But so okay. The problem is here you have negative weights, right? So you can't use something like Dijkstra or something. It's just the exchange rates of the weights. Okay. Let's talk after, because I think maybe it's.
Can you explain this in layman terms? Like, I saw this line, okay? I still don't get it. So yeah, for someone like me, okay, can you explain it like I'm 5 years old, please?
Maybe 10.
It doesn't matter. Basically. This is just the slides will be available. If you're interested in like writing MEV bots, I'm definitely looking for collaborators. We're looking for collaborators. Please come talk to us. Otherwise, forget about this. It doesn't matter. Just know that there's arbitrage opportunities between like everything. So just always be kind of mindful and use DEX aggregators, I think.
Yeah, that was my question. Would I need for this to program a bot or get a bot, program it accordingly, and then my bot creates money for me with the arbitrage?
Yeah, exactly. You can come work with us if you want to make money. Yeah.
Yes.
Exactly, but interestingly, the DEX, like, have people use 1inch or know about 1inch? Anyone? Yes? Good. Okay, a few people. So 1inch is a DEX aggregator, which means it just kind of looks at all the markets and trades for you, right? So instead of you going to Uniswap and trading, it's going to kind of spread your money all across DeFi. It's basically computing this on-chain. Right. That's pretty much what it's saying.
I'm very sympathetic that you need to explain this, but can you not just give an example of like if you're operating on a single forex exchange and you've got different pairs like a USD pound pair and you've got pound and like Canadian dollar pair? Just go through that example because it's fairly easy to understand. Like they just have different prices, right? So
right. I mean, you can go for it if you.
Well, I don't want to answer your presentation.
No, but it's good. Please, like.
No, well, the basic concept is like if you've got a single exchange, right, with different prices on it, you've got like a USD pound pair where like that will have some price between the two assets, right? Then you've got like a pair between USD and Euro, right, and that will have a price between the two assets, and then Euro and pound pair. So you've got like this triangle between the prices. But it's not always equal. Like if you swap between all three pairs, there's going to be some sort of like price difference as you switch between them. So in some cases, it's going to be profitable, and you can like take the difference. Yeah.
I thought that's what I was saying, but okay.
You just had more math.
Thank you.
Quick question. So. You keep mentioning like aggregators like 1inch. Do you have a ballpark amount of worth of tokens where it's useful to use 1inch and when it's not? Because I believe the transaction cost can increase if the route goes through multiple exchanges and stuff, right?
Yeah, but I think they take gas into consideration. I might be wrong. I do think they do, but you might be right actually. But I can't tell you because it's a relative. Basically, I think when I was playing with this, I think it's like if you're trading more than 1% of the reserves in the pool, then you should be going like somewhere else, right?
So in general, it's just a good idea, probably. So even for $100, it might be worth to use 1 inch instead of.
Well,
one
no, but that's
single.
what I'm saying. It depends. Right? If you're trading ETH, like on an ETH DAI pool, like you're trading ETH for DAI, I mean, the liquid, like the volume on these pools is like billions, right? So it doesn't matter. You can trade like millions probably, and you'll be fine. But if you go to like a new token that has like low liquidity, then you're gonna get a lot of slippage. So, yeah.
Okay, thanks.
So when you operate one of these strategies, I imagine this is autopilot, right? 24/7 and scanning the market, trying to come up with what's the next opportunity out there, right? What are the risks? Like it sounds to me that it sounds like a bulletproof system where there's no. What would be the downside? Me as a manual trader, I've been speculating on the markets for 13 plus years. Manual trader, I have to think about the operation risk of the brokerage. I have to think about the stop loss so I can limit my downside. In your case, what are the risks that you are facing when you operate in these markets with an automatic strategy?
No sleep. No sleep. Exactly. You sacrifice your sleep. I think you think about it like high frequency trading. The way I think about it, at least maybe the things about like you have high frequency trading, right, was trading like in the milliseconds time range. Statistical arbitrage where you're probably holding assets for like 5 minutes to an hour, and then like what you're doing, right? So long term, kind of you take an open position in the market. The point is here, arbitrage, you're not holding any reserves, right? So you probably start with USDC or ETH, and you kind of go do your trade, you come back, right? So there's no risk in terms of that. But then you're fighting against other bots, right? So there's basically like MEV is a P2P game, right? So other bots can kind of outsmart you, and if you're trying to sandwich, we were talking about it before, you can get your sandwich can get sandwiched, right?
What can go wrong for your business interests? Can anything go wrong?
Absolutely.
Start losing money, cascading, and like
absolutely. So
ending up minus 10%, minus 20% on one operation. Well, depending on your risk.
I think we have an example of this, right?
I'd love to hear one of those cases.
Okay. Here's the case. There's a liquidation bot that paid, I think, like, what was the amount? I forget. Like $18,000 of gas for one transaction to be the first liquidator to liquidate that position. Somehow, I don't know how it happened, but he just like set his gas limit a bit below the amount of gas needed, right? So then you revert and you lose all your gas. So he just paid $18,000 for nothing. So there's always this. There's also, if your bot sucks, you're always a bit behind the others, or you're trading a bit more. You're paying gas fees all the time, right? So that on Polygon, if you look, like 50% of transactions on Polygon is just spam from bots trying to like take slots, and some of these bots are spending like $1,000 to $10,000 a day just sending garbage transactions, right, to fill the mempool with garbage. So if you're not making profit, like you do have fixed costs, right? Also your servers, if you're running AWS server, it's I don't know, it's like it can be a lot of money, right, running because you need like super bare metal, like very fast servers. So you have operations costs. If your skill set is not good enough, like then okay. Okay, I promise the rest is going to be easier. There's like more graphical. This was just like, So liquidations, let's go faster, but basically, to make this kind of timely, have people heard of Suju getting liquidated and 3 Arrow Capital going down? And yes? Okay, awesome. Yeah, Celsius, exactly. So then the big question is like, kind of centralized versus decentralized liquidations, right? So recently I was trying to write a bot on DYDX, and then they actually recently moved to L2. And it so happens on L2 you have a centralized operator, so it's basically now kind of decentralized FTX. They run their own liquidators, you can't run a liquidator anymore, right? So there's always this tendency, but the fact is on chain, when there's a liquidation event, then you have like the swarm of MEV bots that are coming in trying to take it, and then just outbidding themselves. But graphical pictures for what liquidation is. I don't know if I need this, but basically you put collateral in the pool, you borrow against this amount, and then you have kind of a liquidation threshold, which means if your collateral falls below this threshold, your position becomes open for liquidations. Any bot can come in and basically repay your debt, and that will buy a portion. Basically, he's buying your collateral at a discount. Usually, it's like 5 to 10%, right? So liquidation bots basically they need to borrow this amount, they repay your debt, and then they get about like this amount of value. The problem is they need to compete on the fees to pay for their gas fees, right? So this will definitely like kind of chip into like their profit margins. So the game is there basically. Whoever can optimize their contract to pay the least amount of gas to perform the liquidation will be able to outbid the others and win the liquidation and make like, I don't know, 3%, 2%, whatever's left. Yeah, so here we have an example. Let's say you deposit UST as collateral, right? UST tanks. It goes down. Your debt becomes liquidatable, so someone comes and repays. So this is just a fraction. Often the protocols don't allow bots to repay the entire liquidation because it's kind of unfair. So I mean, it's not that unfair for the user, but you still get a discount. So this is Aave V2, and then you can see that basically, okay, this will be actually interesting. So anyone who's does anyone actually borrow money from DeFi? I don't personally, but 1, 2, 3. Awesome. Kind of cool. So if you do, basically, you have to look at the LTV, which is a loan to value. Seems like I'm missing a syllable here, but this says that you can borrow up to 75%, let's say, DAI against the value of your collateral. And then the liquidation threshold, right, it means if that value, if your debt becomes 80% of your collateral, you become liquidatable. So what people do, even though there's these you can borrow up to 75%, usually people will only borrow like 50% or something just to stay safe, right? They want a bigger margin because prices can tank 30%, right, as we've seen. Yeah, so be safe. If you're borrowing from Aave, just go to your UI very often. Look at this. Yeah, oops. Yeah, look at this. There's your health factor on your dashboard in big. Just make sure that this value is not dropping below what it should be.
Can I ask a question?
Yes, please. Oh, yeah.
So if there would be no liquidation bots, would these liquidations that we just saw with this cascade of liquidations, they would have not happened in that amount, so we would not be in this situation right now.
Okay, that's a good question. Thank you for asking this. I meant to ask basically, so MEV is not like a bad thing, right? Maybe we've been framing it as it's a bad thing, like some bots are stealing your money. It's actually not. So I bought soju last night. I paid probably, I don't know, 7 times the amount that I would pay in Korea. But I was very happy with my soju and it was very good. So I'm happy that there's someone, right? This is literally like arbitrage, right? He's just buying Korea, bringing it here, selling me soju for 7 times the price. That is a function of like a well-functioning, decentralized system. So someone's doing that function, making me happy. I'm like ready to pay some money. Same thing on markets, right? We kind of want markets to be kind of even all across, and you don't want the price to be crazy because then users get scared. It's like, okay, every time you want to trade, you need to look at like 70 different products, and okay, where am I going to trade? And so to answer your question, so it's a good question. Basically, so MakerDAO in 2020, I think, is a good example. At the beginning of COVID, they had this like set of liquidations that happened, and the chain was like extremely congested, and MakerDAO have this. I mean, at the time, now they changed it, but they had their auction system for the liquidation was 6 hour long, and you had to come in and kind of outbid people like slowly but surely, right? What happened during the period of 6 hours, because the chain was so congested with like people using the chain for whatever other reason, there's not a single liquidator that was able to put his transaction in. So all the collateral was sold for $0 by someone who actually clicked on the UI on the website after 6 hours or something stupid. Right? So if you look at I think on Flashbots, and you look at like the MEV extracted per day, there's like a gigantic spike in 2020. That's pretty much what happened. So that comes back to MEV is good, right? Because otherwise the protocols, they end up with bad debt on their balance sheet. So when UST tanks, so basically the protocol Aave or whatever is very much ready to spend 10% or whatever to give to the liquidator bot because they get rid of a crappy asset UST that's tanking, right?
Okay.
So if they keep it, then it might just go to zero. So they're, it's kind of a trade-off.
Okay. Oh.
Good. Okay. Okay, let me run through this quickly. So for the rest of this, I just want to show opportunities where if we've been kind of showing that MEV is kind of bots eating users' money, sorry. Here I want to see other cases where bots are eating other players in the ecosystem's money. So just-in-time liquidity, if you've heard of it on Uniswap v3, is basically bots who are sandwiching the liquidity providers instead of the traders. Right, so they're stealing basically the passive liquidity providers, and this is again creating kind of a centralizing force because it's kind of coming back to the good old, market makers that have like a gigantic hedge fund and control like the float orders. Because on Uniswap v3, you need to be market makers need to be super savvy, technically savvy, and have gigantic teams to manage the money because you can always kind of remove it, replace it if the money's moving a bit. You kind of change your positions. So some people kind of advocate that we should go back to Uniswap v2, kind of be less efficient, but it's kind of the ethos of DeFi. You want things to be, like anyone can put money as a liquidity provider in a pool, right? It's not only the hedge funds that are making money off of everyone's back. So that's that. Generalized front running. This is basically bots eating other bots' profits, right? So we had bots eating users' profits, bots eating the liquidity providers' profits. Here it's bots eating other bots' profit. So what happens is if I'm a liquidator or anyone that finds opportunity on the blockchain, I send my transaction, there's a bot that is running like a local copy of Ethereum. He will take that transaction, run it in his local copy, change my address for his, see if it makes money. If it does, he will just send that transaction before me bidding a bit more than me, and he will like really steal the profit. Yeah. Okay, maybe we should take a small break. I don't know. How's the pace? Is it okay? I can go really quickly to the end. I don't know if people are tired. This seems like a... Are you guys still following? Yeah. Yeah? Okay, awesome. Okay, let's go through this really quickly. I think this is important in the sense that so all the other section was just finding the MEV opportunity, and here it's executing. So here it's much more, you need to know the blockchain that you're playing on and what are the different auction mechanisms. Let's go quickly through this. This might be the most valuable slide, so listen to this and then the rest you can see. So I studied a bit of robotics. I like to think in terms of basically a robot acting on the world and then the world giving observations back to the robot. In the financial system, your robot is like, some MEV bot here, this Flashbot icon, and the world is Ethereum, right? So we've seen basically that MEV bots are finding these opportunities for MEV extraction by observing the state of Ethereum through these different ways, right? So you can basically listen on Infura or any kind of public endpoint, but here you're slow. So most MEV bots will run their own infrastructure on some Amazon EC2 server. And if you have a shit ton of money, you can go to BlocksRoute and pay like, I don't know, some crazy amount per month, and then you have access to kind of a public P2P network that will send you, basically just send you transaction to the miners respective everywhere much faster than anyone else. Again, the centralizing force behind all of this. Let's continue. So now we found the opportunity, and then we just need to execute it, right? So the question is, which chain am I on? If I'm on a proof of stake chain, then basically the validators are like determined deterministically, so you can know in advance on most POS systems who is going to be the next miner. So you can also optimize for the location of your AWS server by making sure that you're super close to that thing. So again, coming back to the HFT world. PGA versus flashbots, we talked about this a bit, but if you're on a chain that has flashbots, the way you extract MEV will be 100% different. Not the same game at all. Flash loans are a very cool thing. Has anyone heard of flash loans? Yeah, awesome. Okay, so flash loan, basically, if you're someone like me that doesn't have that much money, you wouldn't be able to compete, right? Because you find an arbitrage opportunity, but you need like $2 million just to execute it to make like 1 or 2%, right? Flash loans, what they do is you go to Aave, either a lending protocol, Uniswap also has it. You can borrow as much money as you want. You can borrow like all the liquidity in the pool, do whatever you want, right? So you can also hack people or like steal money. And as long as you bring it back with a 0.09% fee at the end of your transaction, you're good to go. So basically now it means that the small players like me have access to like unlimited amounts of capital to be able to participate in these games, right? So this is probably like the most important thing that makes DeFi different from like CeFi kind of trading. You have access to capital instantaneously. The only problem is that not that true because you're paying 0.09% fee on top of it, which means like the people who are not, because they have money, just have that profit margin on top of you, so they can win the auctions. So I mean, yeah, it's there, but it's not there. It depends. And then there's these things that can help you manage. But let's forget about this. Okay, so quickly, what is Ethereum? It's just a scarce computing resource, right? There's a lot more demand than supply, which means that's essentially why we have a mempool, right? Because there's too much demand, so we have to wait. They queue up, and then okay, what do we do with this? So the way that most blockchains go is they just go in an auction-based system, right? So either you have a transaction pool with open bids, then you have legacy transactions with EIP 1559, doesn't matter. Otherwise, you have Flashbots, which has a sealed bid auction system. So already this is way different, right? Because when you're bidding, if I bid, someone outbids me, I don't know. I don't have that information. I did in PGA, and that's why we can have like the bumping transactions of people outbidding each other. Flashbot, this doesn't happen. So people now are paying like up to 98% of their profit margin just to make sure that they kind of win. Which sounds stupid, but at the same time means that 98% of the capital is going back to miners who are securing the chain and making your money more, like your ETH more secure. So it's a trade-off. Otherwise, you can go with the time-based system, right? First in, first out. Forgetting the technicalities, basically, the problem with this is that you need a clock, right? So how do you get a clock when you're a decentralized system of miners? You can use something like NTP, which is what is used like in your computer. Basically, whenever you look at the time on your system, it's synchronized if you've been offline for a while. The problem with this is now, okay, you're a decentralized blockchain, but you have a centralized time source, right? So that creates a vector of attack, not super good. Otherwise, there's systems like Solana's proof of history, and I think Cosmos has this BFT time, which kind of, they're a very different way to create kind of, now time becomes part of the consensus on the blockchain, so you can use that as part of your mechanism. I don't know that much about it, but I'd be super happy to talk to anyone that wants to talk about this. Otherwise, you can have identity-based, it doesn't matter. This is a flash loan I was talking about, right? So I think I've explained, but graphically, if you're trying to arbitrage between two pools, and here you need $2 million of USDC, you can borrow. So this DYDX does not have flash loans anymore, so you need to go to Uniswap or Aave. But it's the same idea. You just borrow that money, you perform the transaction, and you repay. There was a gentleman before asking about like the risk. The thing that is cool about this is that you're doing a lot of transactions, which on a centralized system would be very risky because one of them cannot go through, right, and then you're screwed. But the fact that the blockchain is atomic, it makes sure that your transaction completely goes through. All of this goes through, or none of it goes through. So if you borrow your money, you start doing the arbitrage, you exchange here, you bring back the profits, you actually realize that you haven't made profit, the whole thing cancels, and you're only paying gas fees. So a string? Okay, if I repeat, so you're saying they won't allow you to perform the whole loop if there's at some point doesn't work. I don't think it's true because if you don't have a require check in your smart contract, you can actually do it all, and then in the end you're just losing money. But I see. Okay, sorry, I see what you're saying. You're saying you won't if you don't have enough money to repay There's 0.09%. Yes, absolutely, that is true. That is true. That is absolutely true. That's true. Thank you. Yes, that's absolutely true. Yeah. So yeah, basically the flash loan system won't even, it will revert your transaction for you, but you're still paying the gas and. Yeah. There's a lot of ways to mitigate MEV. Let's get this. But okay, basically it comes down to, is MEV a good thing or a bad thing? Now you need to go into a lot of details about what is good MEV, what is bad MEV, kind of segregate it, find ways to control for the, like keep the good MEV, but just get rid of the bad MEV. That is obviously impossible, right? So it's just all sorts of trade-offs that are very interesting. ETH2, we're just about done here, but ETH2 is coming up with this thing called a proposer-builder separation. So PBS, if you look at the literature, basically it's like flashbots on steroids. So now instead of having searchers send bundles, which are like 1, 2, 3, 4, 5 transactions together, like the sandwich let's say would be 3 transactions. Now the searchers are proposing the entire block. Right? So they just need that much more compute, that much more crazy. But the point of that is that now you isolate all of the miners, or I mean the stakers in this case, which can be like super simple code, and so it's always the case you want to kind of segregate the centralizing power of MEV extraction because you need like smart people and like big computers and stuff. And now the proposers who are actually securing the ecosystem can be very simple, run on simple hardware, and then it goes with the ethos of Vitalik trying to keep the Ethereum ecosystem kind of decentralized. MEV boost, it doesn't matter. I think I'm done. Conclusion, there's no conclusion. These are references that I will post the slide. Thank you for staying until the end. Yes, please.